Dr. Dan Oerther. Dr. Oerther is a professor of civil, architectural, and environmental engineering at Missouri University of Science and Technology. He is an American science diplomat, social entrepreneur, and professor of environmental health engineering. He is vice president of the American Academy of Environmental Engineers and Scientists. Dr. Oerther.
Dr. Abram, thank you so much for that kind introduction. I really appreciate it. And I really appreciated your remarks to open this session. As being the last speaker, my slides are perhaps maybe a little less detailed, and I'm trying to leave you with perhaps maybe a broader view of next things we might undertake. And this is going to be a little bit different talk for environmental engineers and scientists. I'm talking about how do we use insurance to promote community resilience. Now, my slides are posted on my Twitter feed. So for those of you that like to actually see the slides or have copies, the JPEGs are up on Twitter. So just hop over and look at that Twitter handle of it at Daniel Oerther. And I'd love for you to comment and make some points there as well. On the next slide, we're going to see the actual objectives of this presentation. There we go. So there's 3 learning objectives. I'm trying to get you to leave here learning 3 things. Number 1, sustainable development includes more than meeting immediate physiological needs. Much of what we do in environmental engineering and science is around meeting immediate physiological needs, access to clean water, access to toilets, access to clean food, right? These are the things that we've historically done. But sustainable development, what we're doing at the United Nations between now and 2030 means more than that. And we're going to get into that in a second. Also, environmental engineering, particularly in a world that's thinking about adapting to a changing weather patterns, to a changing climate, means that we need to become part and parcel of this idea of building back better. The world needs to be built in a way to address what the future looks like. We need to be imagining that, our kids right now going to school are going to retire into a world of 2065, 2075, right? So the things we're building now have to be able to exist into that world that we have a difficult time even imagining. And so that means that we need to design systems to come back better. Also, and as I think this is a theme throughout this entire meeting, but especially in this particular panel, the way we teach and practice and the way we engage with policy and environmental engineering must truly leverage convergence. And I'm going to get into this at the end of my talk about what that means to me and why I think that's important. So on the next slide, we're going to see kind of, the background that motivates this. Now, I think all of us in environmental engineering have seen this definition from our common future. What is sustainable development? Well, it's meeting the needs of the present without compromising the ability of future generations to meet their own needs. And I would suggest to you that many of the times when we talk about this definition, we talk about the timeliness of it. We talk about the consumptiveness of it. Let's not be gluttonous because this is good for our children and our grandchildren. Let's not overconsume. And those are certainly important things to come out of this, but I'm going to have us key on the word needs. What's a need? Is a second pair of tennis shoes a need? Is a raincoat on top of a winter coat a need? What do we mean by needs? So when we turn to Maslow's hierarchy of needs, a great tool from motivational research to understand, what do people need? Well, the bottom rung is the physiological needs. People need food and they need water. And we understand that as environmental engineers and scientists. We work on providing that to people. But oftentimes we stop there. And so we kind of operate in this world of the have and have nots. There's those that we've helped with physiological needs and those we haven't helped. And so we do things that help get people access to meeting those needs. But I would actually posit or argue that more than that is we need to look up the pyramid. We have the ability to contribute to safety and security, to love and fellowship, to esteem, right? We have the ability to contribute in more than just meeting the physiological needs. And this is where the sustainable development goals, this on the lower right panel, these 17 goals that the world is doing between now and 2030 become so important. So if you're not familiar with them, I urge you to become familiar with them. Yes, it's about getting water filters to folks and it's about improving water systems, but it's about making those systems be secure so that they continue to deliver water even when there is a drought. And you notice I didn't say if there was a drought, I said when there's a drought. So we look at the next slide. Development. Between now and 2030, between now and 2050, forever, development is always interrupted by disaster. This is shown here by this circle on the left-hand side. We have a response to a horrible disaster. We end up recovering from it in some way. And then as we go forward with development, we try to mitigate what would be future disasters. We try to prepare for future disasters. So we used past experiences with SARS to be able to prepare for this current experience. We're right now rushing a vaccine out based on past experience, which will make us be able to recover better in the future. And certainly technology contributes to that, but financial systems contribute to that. So this is the gecko from Geico, right? We all know that. Do you have insurance? Well, insurance is one of those financial instruments that we as engineers can make contributions to. All insurance is underpinned by models. And we as engineers understand system thinking. We understand and create models. If we can create the right kind of models, we can incentivize the right kinds of behaviors. So we know that our life insurance costs less if we give up smoking. We know that our health insurance costs less if we get more exercise. Imagine if we incorporated climate resilience into insurance. What would that look like? Could we incentivize the right kind of climate behaviors because we created good models to underpin wisely developed insurance policies? So on the next slide, I'm going to say, we actually have done this in environmental engineering and science. Reduce, reuse, recycle. It's not insurance, but it is a financial instrument to nudge behaviors. The idea of a financial benefit from recycling your plastic bottle. That is a nudge behavior. That is a fantastic tool for causing people to approach the world slightly differently. And that helps, it complements, it's synergistic with our technologies. So as we'll see on the next slide, I've been working on how to help the Caribbean fisheries industry deal with the changing climate. Practically speaking, the oceans are getting warmer. There's more CO2 in them. Fish migrate in different ways. There are worse and more storms through the Caribbean, and the fishing industry is highly susceptible to those storms. So how do you convince fishers to use slightly better nets, to not drag things across a reef, to not use such small nets that they capture the little fish in addition to the mature, larger fish? How do you incentivize the behavior to move to an inboard motor versus an outboard motor, to not have as much marine pollution? Well, we've designed an insurance scheme so that fishers build back better after the damage of a storm. Now, this same tool is being applied to disease outbreaks like COVID. Now, in case of COVID, the proverbial horse is out of the barn, right? We can't make an insurance scheme for COVID because we're already living through it. But what would it look like if we used insurance schemes to help incentivize vaccine uptake? I mean, we've rushed to create a vaccine, and now the discussion is, do we or don't we really trust that it's safe to get this rushed vaccine? Both people that like vaccines and people that don't are starting to raise concerns. And we haven't thought about, how do we have an insurance scheme in there? How do we make people feel safe and secure that the vaccine is something they should go take? Because it is safe for their families, it is safe for their loved ones, right? These are the kinds of places where engineers creating models that describe risk, that communicate that risk accurately, that link finance to people, to the planet, things that we do in environmental engineering. Here's where we can make some contributions. For those of you that'd like to know more about it, on the next slide, I've got some bibliography. And here's where I think we really need to move ourselves. I've got a paper that discusses how I came up with COAST and worked on that in partnership in the Caribbean. But the three papers that, if you haven't read, I highly recommend you read are Mihalchik's 2017 paper in Environmental Engineering and Science, where he and his colleagues describe how much broader a view we need to have of environmental engineering, how much we need to return to our roots of addressing health issues more broadly. It's not that we shouldn't do lab experiments and not that we shouldn't continue to make activated sludge work a little better. It's that we have an obligation to do more. We have an opportunity to do more. And then I really like the paper by Edwards and Roy, again in Environmental Engineering and Science in 2017, that raises this specter that perhaps we're incentivizing our own field in the wrong way. And it directly plays into this recent paper by Montoya et al. In 2020. If we want people to engage in community research, if we want people to be truly convergent in environmental engineering, we must change the way we evaluate promotion and tenure. We must change the way we support faculty wanting to work in these action research areas. Last slide, please. I told you I was going to try to convince you of three kind of learning objectives here. I hope I've convinced you that sustainable development means more than just meeting our immediate physiological needs. I hope I've convinced you that environmental engineers have an obligation and opportunity to help build back better, and that that's where resilience will come from. And then I hope I've convinced you that there's a lot of smart people out there that are pushing hard to say that we need to change our way that we look at teaching and practice and policy to truly leverage convergence. Thanks for your attention. I appreciate you being here.